So welcome to this lecture. Here in this session I will discuss about the representation of discrete time signals in terms of impulses. So what is discrete time signals? So far we have discussed about continuous time signals. So there is another category, that is discrete time signal. You know what is discrete time signal means? The signal is discretized in time. Okay, see, look at here. This is not a continuous signal. See here, -2. This is a time axis, and normally it is represented as n. Here in discrete domain, we represent this axis as n, and this y-axis, it is normally the amplitude. Okay. So look at here, -2, -1, 0, 1, 2, etc. That means the time is discretized, but there is an amplitude. For -2, they have an amplitude of 1 unit. Then at -1, it is having an amplitude of 2. Then at 0, again 1 amplitude. 1, again it is 2 amplitude. 2, again it is 1 amplitude. Like that it is going. That means at 2, it is having a value. Then at -1, it is having another value. In between -2 and -1, there is no value. That means at exactly at -2 point, the signal is having a value. So that is discretized at a particular time. See, another time period is -1. Then another time, zeroth time, zeroth position. You can call it as position also. First position, second position, like that. So the signal is discretized, but there is an amplitude. Okay. This we can call it as x of n. So suppose this is the signal x of n. Okay. In time domain, in continuous time, we call it as x of t. Here in discretized domain, we call it as x of n. You know that impulse function. Always we studied about impulse. Why? Because with the impulse response, we can identify the response of a system. So impulse response is nothing but natural response of the system. Okay. So before studying all the systems, we look onto impulse. What is the characteristics of impulse? What happens if the signal is multiplied with that impulse? All those things we will check out. After that only we are going to another kind of signal. So first we normally, in all cases, we study about this impulse, del of n. There you know what is del of t. Okay, del of t, you know what is del of t impulse. Exists at a time t equal to 0, del of t equal to 1 at time t equal to 0. Del of t, there exists an amplitude at time t equal to 0, and all other times there is no amplitude. Similarly, del of n represented like this. See, at a position 0, at n equal to 0, we have an amplitude. Amplitude is 1, and for all other time duration, or for all other time interval, there is no amplitude. Okay. So that is del of n. So del of n can be represented like this. So now the thing is, what happens if x of n is multiplied with the del of n? If this x of n is multiplied with the del of n, what will happen? Okay. See, this is x of n. So this is x of n, del of n. You multiply x of n and del of n. So you know at -2, here amplitude is 0, here amplitude is 1. 1 into 0, 0 only. At -1, here amplitude is 0, here amplitude is 2. So 2 into 0, 0 only. At 0, here it is amplitude 1, here also amplitude 1. So at 0, both signals are existing. So multiply the amplitude. 1 into 1, 1. So the amplitude is 1 at time t equal to 0. At time t equal to 1, what will happen? At time t equal to 1, here it is 2, here it is 0. So 2 into 0, 0 only. Here at time t equal to, or n equal to 2, what is amplitude? Amplitude is 1. So here at n equal to, amplitude is 0. 1 into 0, so it is 0. So the amplitude is 0 here. So x of n, del of n, you will get a signal like this, or the signal representation is like this. So we can summarize it as x of 0. So this is the general representation of x of n, del of n. Okay, x of n into del of n. So now another signal x of minus 2 into del of n plus 2. What will happen? Let's check x of minus 2. First you have to draw x of minus 2. So x of minus 2 means, listen here, so at minus 2, see this is x of minus 2, that means n is minus 2. At minus 2, what is the amplitude? 1. Del of n plus 2, what is it? Del of n, you know. What is del of n plus 2? Del of n plus 2 means this discrete, this axis, the point become minus 2. No, that we discussed in signal transformation, signal operation part in this module. Signal operation part, we discussed all of things. What happens is f of t plus 2, t minus 2, minus t plus 2, all those things we discussed. So you refer that. So you know what is del of n plus 2. Del of n plus 2 means this is del of n. What will be del of n plus 2? It is a signal like this, del of n plus 2. How can I draw del of n plus 2? This I can draw like this. At minus 2, it is having an amplitude of 1. And for all other minus 1, 0, 1, all those things, amplitude is 0. So that means it is shifted. Time shifting only. Okay, that is del of n plus 2. So del of n plus 2 means at minus 2 it is having an amplitude of 1. And here also x of minus 2 means at minus 2 it is having an amplitude of 1. So both you can multiply. So what will happen? 1 into 1, 1. And that is at minus 2. So 1 into, here it is minus 2, at minus 2, here also at minus 2, both having an amplitude of same 1. So multiply those amplitudes, you will get 1 here, and where it is happening, so it is there at minus 2. Clear? Now what will happen if x of 2 into del of n minus 2? So what is x of 2? So you know what is x of 2. At x of 2 means at n equal to 2, it is having an amplitude of 1. So that you know. Now the question is, what is del of n minus 2? How to draw del of n minus 2? Del of n minus 2 means it is a right shift. Here it is minus, means right shift. If it is plus, it is left shift. That you know already. Okay. So del of n minus 2 means this is shifted to plus 2. That means at plus 2 it is having an amplitude of equal to 1. And here it is x of 2. X of 2 means at 2 it is having an amplitude of 1. So what will happen at 2? Both signals having an amplitude of 1. So definitely we can write like this, 1 into 1. Here it is 1. Here also it is 1. So at 2, at n equal to 2. So amplitude is 1. So that's why we written like this, at 2 equal to 1. Now another thing is, what happens if the x of n into del of n minus 1, x of 1 into del of n minus 1. X of 1 means at 1 amplitude is 2. See, at 1 amplitude is 2. So x of 1 means 2. Del of n minus 1 means it is a right shift. So this becomes 1. At 1 it is having an amplitude of 1. So x of 1 to del of n minus 1 means at 1 it is having an amplitude of 1. And for this signal at 1 it is having an amplitude of 1. So 1 into 2, 2. So at 1 it is having an amplitude of 2. So that's why it is written like this. Okay. So now you can summarize like this. So x of 0, for example, take this, x of minus 2 into del of n plus 2 equal to, which is nothing but x of minus 2 only for n equal to minus 2. That means at n equal to minus 2, del of 0 is 1. 1 into x of minus 2, x of minus 2 only. That is a mathematical representation. This is the graphical representation. So what will happen if n is not equal to 2? Definitely the 0 will be there. Why? Because for all other times, if n is not equal to 2, that means under that condition, for all other values of del of n is 0 only. Okay. So that's why it is written 0. So similarly, how can we write like this? Write this equation: x of 1 into del of n minus 1. X of 1 into del of n minus 1 is nothing but x of 1 only. Nothing but x of 1 only. That means for n is equal to 1, you put n equal to 1 here, 1 minus 1, 0, del of 0 only, no? So del of 0 means 1. 1 into x of 1 only. So x of n 1 into del of n minus 1 is nothing but x of 1 for n equal to 1. What will happen if n is not equal to 1? Definitely this term will be 0. Why? Because the signal is exist at n equal to 0. Okay, if you put other than 1, n value other than 1, the del of this quantity, del of for example, you put it as 2, del of 2 minus 1 is 1, del of 1, what is the value of del of 1? 0 only. That's why it is written for n not equal to 1, all the amplitude of impulses become 0. So 0 into something, 0 into x of 1, nothing but 0. Like that we can conclude. This is the representation of a discrete time signal.